Yeah, in this section, we'll be looking at reducible to variable separable. And when we say reducible to variable separable, what does that mean? It means there are some questions that falls on variable separable, but we find it very difficult to separate the variables. We find it difficult to separate the x and the y. So since it's not very easy to separate, what do? We reduce the question in a way whereby it will be very easy to separate. So we call it reducible to variable separable. Share. Now let's look at this first example, and let's use this example to explain. Okay. Now from the look of this example, if we actually to separate what is here, because this is this side a bracket and is attached to a power, if you are to expand this bracket, you end up having something like 8xy in between. When you expand the bracket, you know now 4x times 4x 16x squared plus 8xy plus y squared when you expand this bracket using binomial expansion. But because of this, there's no way you can separate it. Xy cannot go separate, y cannot go separate. You get what I'm saying? So because of that, and we are to use variable separable to solve the question, what do? So we can say that let z equal to 4x plus y, comma. If I'm to differentiate z with respect to x, what do I have? You know, this will be in form of a variable. This will be in form of a variable. Now, if I'm to differentiate that, I have it to be, if you differentiate 4x with respect to x, I have 4 plus, if I differentiate y, implicit differentiation, if I differentiate y with respect to x, I have what? dy dx. Okay? Now, since I've gotten this, I can make dy dx the subject of the formula. Therefore, dy dx is equal to dz dx minus 4. Okay, now we've gotten the value for, in replace of 4x plus y, we represent it with z, and in replace of the y dx, we represent it with this. Okay, so I can say that, let's go back to our question. Now from the question, we have this to be z, that's z square dx dy is equal to 1. Okay, now dx dy is the same thing as 1 over z square. Now if I'm to get dy dx, that's reciprocal law. Dy dx will be the same thing as what? Z square. But what is dy dx? Dy dx is this. So in replace of dy dx, I can just substitute this by saying it's the same thing as dz dx minus 4 is equal to z square. Now, at this point, I've changed the variables from x and y to what? Z and x. Here you get. Okay, so from here, I have it to be dz over dx is equal to z square plus 4 by taking minus 4 to the other side. Okay, so at this point, I can, separate them. If I'm to separate this, I have it to be, then I have it to be dz over z squared plus 4 is equal to dx. After separating, we integrate both sides. Then when you integrate both sides, if you integrate z squared plus 4, recall standard techniques. The standard technique says that, let me write it at this corner. The standard technique says that, the integral of 1 over x squared plus a squared is equal to 1 over a arctan of x over a, from our standard techniques of integration. Now, by comparison, my a square will be what? 2 square. Okay, so what is there is the same thing as 4, but that's what? 2 raised to power 2 in form of a square. Now, if I'm to use this techniques to solve that question, then my answer will be 1 over 2 arctan of z over 2 which is equal to, if I integrate this, I have what? I have x. Sorry, if I integrate 1 with respect to x, I have x plus c. But what is z? Recall, z is the same thing as 4x plus y. Then I can say my answer is 1 over 2 the arctan of 4x plus y all divided by 2 is equal to x plus c. Okay, I can multiply through by 2. If I multiply through by 2, then I have it to be the arctan of 4x plus y over 2 is equal to 2x plus my constant c. Final answer. Okay, so that's what we call reducible to variable separable. Thank you.